All right, time for a little review on sequences. So sequences are just a list of numbers. They follow some sort of pattern. We mainly focused on arithmetic and geometric sequences and writing functions to describe those sequences. So if you're the kind of person who likes having notes, here's a bunch of notes. We would write recursive functions to describe sequences, whether they're arithmetic or geometric. And they would be in this format. So recursive functions describe the pattern, and they say where the function starts. If you have an arithmetic sequence, which means it's adding or subtracting the same number each time, such as starts at 3 and it's adding 2 each time, so 3, 5, 7, 9, 11. That'd be an example of an arithmetic sequence. And arithmetic sequences have a common difference. That's what this D is, so it's a common difference. Geometric sequences, on the other hand, are multiplying by the same number each time, which also means you can have dividing by the same number each time. But the thing is, if it does have a pattern dividing by a number every time, we just turn that into multiply by a fraction. And so an example of that would be something like 50, and then 10, and 2, and then 2/5. The pattern on something like this would be dividing by 5, which would mean it is timesing by 1/5. And this number, the thing you're timesing by, is your common ratio, the R. Common ratio. And it fits in the formula like this, if you're doing a recursive function. If you're doing explicit functions, then there's not two equations, it's just one. And in the equation, you have common difference and your first term of your sequence. You have your first term of your sequence and your common ratio, if it's geometric. And you're going to replace these with the actual numbers that go there. So let's try that out on a few examples from your review. Once again, you may want to write this down on your note card if you'd like to have a note card. So let's look at a few examples. So number one here, we got this sequence. It has a specific pattern. This pattern where it's switching signs each time gives you a good clue that you're timesing by a number. This is times by -2. This is also times by -2. This is also times by -2. So as this pattern of timesing by -2, that's a weird start thing. And that means this is geometric. And now I'm supposed to write the recursive function for it. So the recursive function, if I use my function notation, f of n equals f of n minus 1. All your recursive ones start like this. And what you're going to do is now fill in what happens to the previous number to get the next one. Well, in this we already talked about. It's timesing by -2, so you can put times -2 here. But more often we put -2 in front because that also means times. So it's every number is equal to the previous one times by -2. So that's the recursive part. That's the pattern part. This is not done, though. You do have to say where to start. So I'm going to put f of 1, which means the first term in the sequence is -6. So altogether, this says start at -6, and every number is the previous one times by -2. Let's try out another one. Let's jump to... let's jump to the back where we got a little word problem here. Each year you're working for a company, your pay increases by $4 per hour. When you started the company, you made $7 an hour. So first year, 7. Next year, go up by 4. You're at 11. Go up by 4. You're at 15. Go up by 4, 19, and it goes like that. So this pattern of adding 4 each time lets you know that this is an arithmetic sequence, because arithmetic sequences are sequences that add or subtract the same number each time. We know our common difference is 4, so our D is 4. And we know our initial value here, our starting number is 7. So I'm actually going to switch to function notation here, because you do have to be familiar with that as well. So we're at a sub 1 is 7. If you want a quick reminder what that looks like, that's what this stuff is. The difference between a sub n and f of n is just notation. You can replace a sub n with f of n, and it means the same thing. So yeah, we're just switching so you can get used to seeing both again. So right, a sub 1 is 7 and d is 4. So I'm going to write out my explicit function. So I got a sub n equals 4 times n minus 1 plus my initial value of 7. This is not quite done. You do have to simplify this. We're going to distribute that 4, 4n minus 4 plus 7. And now we got our final function here of 4n plus 3. So a sub n is 4n plus 3. So we write out our explicit function. Let's try out another one. Let's jump to 14. This is a graph. It's a little bit kind of a different graph too, but it starts by going up 1, then 2, then 4, and then 8. So I'm going to write that out. 1, 2, 4, 8. And that makes my sequence. 1, 2, 4, 8. That looks like it is timesing by 2. And so that makes this geometric, because geometrics means multiplying by the same number each time. And if I'm going to write the explicit function for that, let's do a sub n again. I need to put my initial value first, which is 1. And then what I'm timesing by to the n minus 1 power. And this doesn't simplify anymore. So that is all done for my explicit. We're going to go over one last example, and that's being able to switch between different formats. So these here are all in recursive format, so the recursive functions, and it's asking us to put it as an explicit function. So I'm going to do C here. Looks like we got every number is the previous one times by 1/3. So if every number is the previous one times by 1/3, that lets you know that it's geometric. So it's geometric. And this here tells me the first number of my sequence. So that's the first term. And so if I'm going to write out the explicit function, which let's do a sub n again, I know I need to put, since it's geometric, I put my initial value first, which is 243. And then I'm going to put parentheses to the n minus 1 power. And the thing that goes in here is what it's timesing by, which we already talked about, is here, is timesing by 1/3 each time. And now I have the explicit function that goes with this. And there we go. So there's your examples. Hopefully that gives you a reminder of how these sequences work out and what the functions are. I'll put all of these on the screen last so you can write them down if you need to write them down. So good luck with sequences.